Okay, this is Pure 2 exercise 6a notes, looking at sec, cosec and cot, the three other trig functions. Okay, so I just quickly want to have a run through where these three other trig functions come from. So when we look at a right angle triangle and one angle, we get three sides. You're used to this, and you're used to seeing O over H, A over H, and O over A. However, there are other combinations of fractions that we can create using these sides. In fact, there are exactly three more, and no more after that. Each of the fractions that you know, all turned upside down, or reciprocated. The first one we call cosec, the second one we call sec, and the last one we call cot. They each have a long name: cosecant, secant, and cotangent, to go with sine, cosine, and tangent. Okay, so that's where they come from, that's what they are. We'll move on to the kind of way you'll be expected to use this in actual work that you'll be expected to do. Okay, the first thing I want to say to you is that you normally see each of these as fractions of sine, cos and tan. And the reason you see this is because the side lengths aren't important, only the angles are important. So what we'll be doing will kind of be using substitutions and algebra and things like that, rather than looking at right angle triangles themselves. Okay, so making a start, just by looking at the equation, we know that when cos is positive, sec will be positive, and when cos is negative, sec will be negative. And that's just by looking at that equation, because they basically have the same sign. So the kind of thing we're going to get asked here is to evaluate sec of 225. Well, we'd treat this just like a normal problem that you can already do, but recognizing sec is 1 over cos is your way of looking at cos 225. That's the way to deal with this problem, is to recognize the equation, look what it is that you can figure out, and go and figure that out. So if we look at 225, it brings us right round to this line here. Cos is negative, so we know sec will be a negative number. And we go up and look at the positive version of cos using the second solution. And it'll be cos 45, which will appear. Now you did this, if you were asked to evaluate cos 225, you can do that. We're just adding this extra bit on that you are translating what sec is. Finally, you can go on and do this without a calculator, but you can use a calculator to evaluate cos 45 as root 2 over 2. Put that in and reciprocate the fraction and rationalise the denominator. Okay, so cosec is equal to 1 over sine x. Again, cosec and sine have the same sign, be it a positive one or a negative one. Okay, so written out formally there, when sine x is positive, cosec x is positive, and same with negative. So if we're asked to evaluate cosec 330, we're thinking about sine 330, not cosec really, and we're going to use our cast diagram to mark sine 330 on. There it goes. And 60 is the angle up to the full circle, so we mark that on. Sine is negative here in this quadrant, so we are looking at replacing sine 330 with negative sine 60. We can figure out what sine 60 is relatively easily using prior knowledge. Okay, and there we come up with our answer. Okay, so looking at the last one, cot of x is the same as 1 over tan of x. And their signs are the same, so wherever tan is positive, cot is positive, and likewise with negative. Now, it's the same idea. We are going to be thinking, not finding out what cot of 5 pi over 4 is, but what tan 5 pi over 4 is. We use our cast diagram to do this. Pi is a straight line, remember, so we are down in the bottom left quadrant, 1/4 of pi. Tan is positive, so we are finding the positive acute angle of tan, which is 1/4 pi, is half a right angle, so think of it as 45 degrees. So we can find out tan quite quickly as being 1. So it's the positive version, 1 over 1. So we've evaluated it as 1. And we are done. We're ready to go. So go and answer some of the questions from exercise 6A, the highlighted ones. Thank you.